This race can be won or lost in seconds. Sails must grab every bit of push the wind has to offer. In all of this, one tool is vital, a simple little force transformer. When the wind is strong and the angle is right, there can be several tons of force pushing on a sail. With so much force pulling on them, it would be difficult for a human to handle them alone. The winches mounted on the deck are rotational force transformers. They transform the torque delivered by muscles into a very powerful torque that is able to handle the sails. In some cases, how that winch is used can mean the difference between winning and losing a race. A force transformer takes work on the input side and transforms it into another form of work on the output side. We have seen in our unit on work that work in a rotational system is done when torque rotates an object through an angular distance, t times theta. A force transformer, like a winch, transforms torque acting through a distance into a different torque moving through a different angular distance. Like other force transformers, a rotational transformer does not create more work. The work out cannot be greater than the work in. It's simply in a different form. To keep the work in and the work out the same, there has to be some kind of trade-off. If the torque is increased, then the angular distance is decreased. The same is true in reverse. If the angular distance is increased, it's at the expense of the torque. Rotational transformers are usually made up of interconnected wheels of different sizes. Wheels can be connected in several ways. One is with gears. Another is by belt. The third is when one wheel is inside the other, a wheel and axle. Let's look at the first case, the wheel and axle. If you consider the axle as a wheel, the whole assembly is really a small wheel within a larger wheel. The wheel and axle is one of the simplest force transformers, and it's one we usually take for granted because it's so simple. But if we look at it in its basic form, mainly by taking it apart, what we really find is that although it's one piece, it's got two components, the axle and the wheel. But they're different diameters. The axle, of course, is very tiny, whereas the wheel has a much larger diameter. Now, it takes a different amount of torque to turn a small wheel than it does to turn a big one. So this will provide a force transformation, and we can see that directly. If we take the axle and we lay it down on a surface, and then we rotate it through one rotation, you can see that it doesn't move very far. If I can rotate it right. There we are. However, if I then take the wheel and put it on the same surface and rotate it through the same angular distance, that is one turn, you can see it goes much farther. So that's the force transformation. That's the mechanical advantage, even though it's only one piece. So when you think of a vehicle, all of the force transformations that happen because of the other gadgets, like the transmission, the pulleys, and the gears, there is still one more advantage that happens right here at the wheel and axle, simply because of the difference in their diameters. Now all I have to do is put it back together. Comparing the size of wheels can be done in several ways. You can measure their circumferences, their diameters, or you can measure their radii. Whichever way you use, you compare the input to the output wheel and find the mechanical advantage. If one is twice as big as the other, there's a mechanical advantage of 2. Some devices, like a drill press, give you a choice of wheel sizes, so you can change the amount of transformation. But remember, comparing wheel sizes is only the ideal mechanical advantage. The actual mechanical advantage will be a little less because of resistance. The wheel and axle is an incredibly simple force transformer because it's essentially one piece. You can see why it's one of the greatest inventions humanity ever came up with. Sometimes it's necessary to connect two wheels that are on different axles. This can be done in several ways, but the way of finding the mechanical advantage is still the same as for the wheel and axle. Compare the size of the wheels. This difference in radius of the input and output wheels also affects the speed at which they turn. So a transformer can be used to increase or decrease the speed in a rotational system. Belts do have one disadvantage. They stretch when they get old, begin to flex, and eventually they slip. The flexing generates unwanted heat, and the slipping, of course, decreases the amount of torque. This makes the actual mechanical advantage less than the ideal, so the efficiency goes down. A chain is a lot like a belt, but it just has teeth on the wheels, so there's no slippage. The mechanical advantage of a chain drive can be found the same way as a belt drive. Compare the size of the wheels. But usually there's an even easier way. Since the chain has to fit onto both wheels, the teeth on each wheel have to be the same size, even though the size of the wheels themselves can be different. That's very convenient because if you count the teeth on the input and the output wheels, you can find mechanical advantage. If there are 3 times as many teeth on the output wheel as there are on the input, there's a mechanical advantage of 3. Counting teeth is also a handy method to use in the third kind of rotational force transformer, gears. Gears are just wheels that are joined at the rims. If one wheel has more teeth than the other, they will turn at different speeds, so torque will be transformed. The difference between a gear system and a wheel and axle, belt drive, or chain is that with the other methods, the wheels turn in the same direction. But in a gear system, the input and output wheels turn in opposite directions. Sometimes this doesn't matter, but if you want to make the input and output gear move in the same direction, just put another gear between them. That's called the idler gear. Idler gears have nothing to do with mechanical advantage. They only change the direction of rotation and direct the torque to different areas. So to find the mechanical advantage of a system like a transmission, you don't have to count all the gears. You only need to count the teeth on the input wheel and the output wheel. There's one other type of mechanical force transformer which is half rotational and half linear, the screw. The screw is really an inclined plane that has been wrapped around a shaft. Torque is applied to turn the screw, and this becomes a linear force. Screws can produce enormous forces over very short distances, but they suffer from very high losses because of friction between the threads. Whether you measure the sizes of the wheel and axle, the sizes of the wheels in a belt drive, the number of teeth in a chain drive, or the number of teeth in a gear system, the mechanical advantage provided by a rotational force transformer enables small power sources to operate very large equipment. Yeah.